Okay. Hey, everyone, and welcome to the August 2021 Gio Community Call. Today's agenda is some project updates, followed by a presentation from John Eaglestrand on his recently created GUI with Gio tutorial. I'm going to hand things over to Elias now.
Thank you, Chris. I've been working since the last time still on the compute renderer. I'm targeting having something development, having the development stopped somewhere in the next month, in the sense that it is complete as I'd like it to have it in this round. And one of the biggest missing pieces were backends that were not OpenGL, and some corner cases that I was so fortunate that some of Chris's programs were hitting. So I've been fixing all these corner cases, which were just they were more or less a question of managing the texture memory in a more clever way. So to allow an infinite, at least as much as your memory would allow you to, an infinite amount of materials and images and transformed images and so on. So that part of the work is done. And as far as I can tell from Chris's messages, it does work for his programs. So the compute renderer should now work for most, if not all, practical workloads that the old renderer can also handle. The more interesting part is the other backends. So up until about a few weeks ago, Pierre. Up until a few weeks ago, the OpenGL renderer the OpenGL backend was the only one that actually supported compute, which means that it would only work on Linux and Android. So the missing pieces were direct 3D support for Windows and Metal support for Apple devices. And I've been completing the Metal port, which unfortunately has, unless I've been doing something wrong, some misunderstanding on how it works, the compute renderer does not work on that many Apple devices. So even the relatively new phones cannot render it without graphical glitches and crashing. And my old laptop, my own MacBook Pro from 2014 does not render the compute output correctly either. So that is somewhat disappointing. The other thing is that the Metal backend doesn't work for everyone. For example, Pierre, who just joined, has a very annoying problem of having graphical corruption in full screen mode. I hope to have that fixed, because at the very least, we should have the Metal renderer as the default and hopefully the only backend for either renderer on Apple devices, because OpenGL is deprecated, it is slower, and doesn't support many of the newer features that the newer machines have. I've also completed that was an easier task because TU already supports Direct 3D on Windows. So I completed that port by adding compute support. And to my surprise, it doesn't work properly on at least my setup either, which is should be more or less standard NVIDIA graphics card, GTX 970, I think. And the compute output is simply corrupted and garbled and hangs the GPU. So that is somewhat disappointing, that the only place the compute renderer actually does work reliably is on some Android phones and most Linux systems. I hope that, because I'm really surprised that the Direct 3D drivers are not mature enough to cover the compute support that we need. So I hope I've been doing something, I'm missing something in my implementation. So that's what the status is right now. I am slowly working towards getting Pierre's problem fixed with the old renderer on in full screen on Macs, and I'm also working on doing the Vulkan port. And the reason for the Vulkan port is that I hope it is redundant with the OpenGL. So everywhere where Vulkan supports is present, which is Android and Linux, there's also OpenGL support in Praxis. So there's no theoretical reason to doing a Vulkan port, but I hope to have more stable Vulkan drivers than OpenGL drivers with respect to compute, at the very least, and hopefully on Android. But also, I believe Chris has been talking about a user of his that has had a problem with the compute on an NVIDIA card in Linux. So I'm working on completing the set of backends to have in total OpenGL, Direct3D, Metal, and Vulkan, just to have them out of the way, so to speak. And then I will spend my time on something else on Gio, at least, and then perhaps on the side debug the issues and report bugs that relates to the corrupted compute output on Metal and Direct3D.
Okay. Well, does anyone have questions for Elias before we move on? Hearing none. John, why don't you take it away?
Yeah, perfect. So I'm John, and I'm fairly new to the Gio community. So what I wanted to show you today is basically just a tutorial I wrote just for my own sake, mostly. Let me just see if I can share this screen. There we go. That's me once more. And here we have the topic of the day. I'm coming to Gio from a desktop background, and I sort of want to use this framework to build, I wouldn't sort of brag and call them complex, but slightly more advanced applications for desktop, preferably multi-window, maybe even multi-screen. That's sort of my goal with this whole dive into Gio. But every journey has to start somewhere, and I started with watching the various YouTube videos which are out there, where Elias, you present the various at various talks, starting with a blank screen, basically just building an application up from scratch. And I said, okay, well, he can do that on screen live. I can probably do that as well, but I can't. So it started out just as scratching this itch. How can I even get a blank canvas, get a window, and just basically iterating from there and documenting the journey as it went along. It has been a lot of learning from me, but hopefully this tutorial will be useful. Probably not for you guys, but when you want to show something to your friends to get them started using Gio, this can be maybe a starting point for someone more or less fresh into this. So that's sort of the background, and I wanted to write something that was assumed absolutely nothing in terms of prior experience. And after a while, add on step by step the various elements that sort of make this interesting. So everything is on this GitHub repo with its own webpage. The first chapter just makes a blank canvas, and for me, that was well, I wouldn't call it a milestone, but it was a step, right? Like, hey, I can actually make this work, and it resizes and everything. This is cool. And step number 2, I just set the size and set a title for a window. Okay, still basic, but we can do that. And so it goes, right? Adding on one element. So in chapter 3, we add a button, right? And we talk about what's going on with events, where do we have state, what is purely presentation, and going into the various pieces of the documentation as well. So I tried to refer back to the various parts in the both Gio documentation, but also Go documentation. And there are some nuggets in here, you know. The whole Go font story, and how these old guys deep into the lore of font creation with Bigelow and Holmes. That's a cool story, right? So if you haven't heard about that, take a look at that. It's a cool story. And it's been a, what do you say, a great learning experience for me, which was my goal, to make this useful at least for one guy, me, but hopefully it will be useful for more people as well. We add more buttons, and not more buttons, but we start to format and use insets in order to do that. Do a little bit of refactoring when the code gets a little bit more complex. We start to add using the flex box, right? And that's a concept, and that has to be sort of explained. It's a great tutorial on Flexbox from Mozilla, which I refer to, which is, of course, quite easy to get into once you know it. But getting into it, it was useful to sort of follow them. I have a progress bar, which starts and stops and has some interaction with us as well. And that is maybe where we had a little bit back and forth, Chris, with regards to how to do animations, how to deal with the invalid operation, which starts to become a little bit advanced. But it turned out to be sort of one of the gotchas for me, at least, right? Two ways to call invalidate. And discuss that a little bit back and forth, the performance versus so visual performance for the user versus like CPU performance for the machine. But these are, you know, bite-sized discussions as we go through the various chapters. So after adding a button and a progress bar, I wanted to add some custom graphics. I think it was around this time I decided to, hey, this maybe can become an egg, and we can have an egg timer as a theme for this whole this whole exercise. Of course, Gio has a built-in circle, right? It doesn't have a built-in egg, strange enough. So, and that was actually quite cool. To find some math that allowed an egg to be drawn. Let's see if we find this webpage, because it's amazingly well animated. Yep, there we go. From Torben Jansen. Let's have a look. It says interactive egg. There we go. Torben has this reference to this formula where you can define the various parameters of something that, if you tune it correctly, will look like an egg. That's two circles, an inner and an outer, an offset, making it symmetrical, non-symmetrical, to tune that just right, and you get a distance from center, which when you go all the way around, gives you an egg, right? Quite a lot of very talented individuals have spent time creating a formula to look like an egg, which I find hilarious. But hey, it works. And we use that when we draw a custom graphic, and that's the whole point here, right? And I really wanted to do something custom. Looking at the various frameworks that are out there, Should I go dive into Geo? Should I look at Fine? Should I look at other stuff? But I want something that is flexible. I can sort of tailor to my needs. I don't really know what those needs are right now, but I really don't want to be boxed in at day 0 by the choices I make then. And then I came across the flower animations from you, Egon, which are beautiful, right? And that just sold me, you know. When a UI framework can make something like the animated flowers, that's a framework that has flexibility. So clearly, in this tutorial as well, I wanted to show that, you know, custom graphics can be done, and it's actually not that hard. And if you, like me, find math formulas for egg to be fun, then why not? So that's the story behind the egg. Final part is where I add a input box and has some logic to update the text inside the box just to count down. And it's flexible. You can start it, you can stop it, you can reset it. And the hope is that, of course, that as a reader, once you have gone through all of these chapters, step by step, you can start knowing absolutely nothing. You can end up knowing enough to get going from there. I tease you a little bit, Elias, about the documentation on geo.org, because at first sight, I didn't really understand it. Of course, that's on me. I'm not an experienced developer. But I wanted people to sort of get up to the level where the architecture document starts to be something you nod recognizably to, right? Ah, okay, now I get it. I wasn't there when I started out, but I think I'm getting there at least now. And I hope that sort of by doing this and following along, people can sort of get to that level if they are starting where I started as a lead goal. So that's the main part of it. You were very kind, Elias, and linked to this from geo.org, which had the benefit of getting quite a lot of, well, not a lot of users. I wouldn't brag about that, but a significant increase at least. So in percentages, this has been significant increase. You can sort of see exactly the date where it happened. Let's go back a few days. Yep, so open August, it was linked, and from there on we had many more visitors. So roughly, yeah, August 12th. So all the visitors before that were just me on various devices. After that, it's actually gained some traction. From US and China, there are some interesting countries. Got some in Nigeria, got some in Djibouti. But the interesting is, that's more fun fact. The interesting thing is this, quite a lot of desktop, not that much mobile. I don't know if that is because people, you know, maybe not everyone is doing everything on their phone. There's hope for the desktop guys as well. I count myself as one of them. So I found that interesting. But very generous, and thank you for the link. I find that, yeah, that was really cool. I really appreciate that. So the egg was, part 1, and it's basically just presenting stuff on screen. I've started out on a next chapter, which is a teleprompter. The whole point here is to show text on screen and have a lot more input from the user in terms of moving text up and down, back and forth, sizing, fonts, and et cetera, The code is done, mostly, but the writing is not done. So maybe another way of saying that, stay tuned. more will come. Any questions, comments?
Well, first of all, I didn't know that you'd started on a new project in there. That's really exciting. I think that your tutorial is probably the easiest entry point Gio has right now. So thank you so much for spending the time to make it so good. And I know that I wanted to elaborate a little bit on the discussion you mentioned regarding the animation of the scroll bar, or not the scroll bar, the progress bar. Because you mentioned that there's a trade-off between kind of the user's perceived performance and performance. And I believe what you meant was that when you tried invalidating every frame to get that progress bar to be as smooth as possible, I can't remember what percentage it was, but you saw the CPU percentage go higher than you expected for just that, right? And that, is because Gio was redrawing literally everything, every frame. But once we have the compute backend working on your platform, I think the auto tiling should change that, such that, because I think that it should be a relatively straightforward tiling problem to solve, right? There's just a single stripe changing. And so I would expect that trade-off to kind of disappear.
I think so too. And it is, as you said, right? I coded up with invalidating absolutely everything all the time. And then changed this. And I'm using a technique is it from Kitchen? Or is it from one of the examples? I think remember. Yeah, where you have this sort of this centralized ticker, right? This channel that just generates ticks every 20 milliseconds, 25 milliseconds, 100 milliseconds. You tune it, and then you basically can send enough validations for it to look smooth, but not too many, so it is overloading the render. And I think I landed on a performance of around 25 milliseconds. That I think that gave me sort of the smoothness I liked. So the performance was interesting. Let me share the charts since you mentioned it. So do you see a set of charts here now?
Yes.
Yeah, perfect. So this is in the bonus chapter, which I wrote after our discussion. So what I did here was that I boiled an egg for 60 seconds, right? And used two different invalidation techniques. One just v.invalidate, and the other using the invalidate op, which is slightly more lightweight. On the left-hand side, it's a CPU load running on my MacBook. And then we can see a little bit of a difference. This is a 2017 MacBook. So it's not super modern, but it's not that old either. You see, I did it on August 8th. I didn't have any updates on the renderer, so it's the old render. But then there's I don't know, you say like 16, 17% CPU load on op invalidate op, but 18, 19-ish on W invalidate, right? I ran the same code on the right half of the chart. Same code, same experiment on a Dell laptop running Windows, and then performance is so low, so there's no difference. So you can tell this story as a glass half full, half empty, focusing on the small difference or the higher level. But I do agree, right? Once we get to the new render, it should probably just flatline. Beep. For both of them. So yeah, it will be interesting to see.
So this was Mac OS versus Windows benchmark, neither of which has the new render code at this point in time. So it's fascinating that there is such a difference.
Yeah, I agree. I've run it on a few different Windows machines. So this is one of them. Definitely not a super powerful computer. It's an i5, 3-4-year-old maybe. Run it on a desktop with a really modern GPU as well, and then it's also nothing, right? But yeah, interesting. I have included some log files and dump files in the repo, sort of document a little bit more what's going on here. But I haven't dug deep into it. It's a little bit above my skill set.
Sure. Elias asked in chat if you've tried the macOS Metal backend that he's been working on with this.
Yeah, exactly. Yeah, no. So I have not actually. I tried running Kitchen on my iPhone, but I didn't get that to spin. So it's a good point. Let me do that. Let me run the new one on Metal here as well.
So what I've seen from the Metal backend, the reason I did it is, of course, to access the compute capabilities to get the new renderer to work on Apple devices. But what I also saw, which I had hoped for, is that, at least on my machine with the OpenGL backend, the iPhone simulator is drawing very, very slowly. Has almost no, let's say, just say 5 or 10 frames per second or something like that. With the Metal backend, it runs, at least as far as I can tell, as smoothly as on an actual device and as smoothly as on the device, the macOS native programs itself. So it may be that some of your CPU uses is from some kind of interaction between the OpenGL rendering and the translation to Metal.
Good point.
But other than that, have you tried the otherwise excellent profilers in Go?
Yeah, so I've tried them. I've gotten some input, and I've included some of this in the repo as well, so it should be accessible if you want to have a look. I have, to be honest, I don't grok them all, There's a problem exists between keyboard and chair when it comes to interpreting all the call graphs and everything. So I looked at it, didn't really find any obvious bottlenecks there, but then again, I might not be the one to find them.
I'd be very interested to hear what the Metal backend does for you, especially if there's such a big difference between Windows and Mac.
Yeah, sure. I'll have a look.
Another thing is you mentioned that the compute backend may be faster than have less CPU usage. I would say probably not. I would say the bottleneck is somewhere else if there's such a big difference between your Mac and Windows systems.
Okay.
And the other thing is that even though the compute renderer does automatic layering, so it doesn't re-render things that it has already in GPU memory. The problem, especially on Mac OS, is that the compositor will re-render everything anyway. Not re-render, but it will recopy everything anyway. So that means, as far as power usage, at least, you will probably not see see any gain from having this automatic layering approach.
Okay.
And with respect to CPU usage, I would say the GPU is doing most of the work. So when you see, is it 30 or 40% CPU usage, it's something else. It's very, very likely something else. There is a few inefficiencies, at least in the old renderer. If you have something more complex that's just a filled shape, such as your egg with transformations, if you transform it animate its transform, it has to recompute the path segments that makes up your outline. And if you have something which is not an outline, which is a line segment, or so if you have a path that you want to draw, what is it called? I forget. So you draw a stroke. Yes, a stroke. If you have any kind of stroke, at least with the old renderer, it will have to at each frame reconvert that stroke into an outline, and that's relatively expensive as well.
Okay.
So the new compute renderer can support natively strokes that are just regular strokes with so that's without outstippling, with round cabs, and without meters or any special joints. Then it can render that as efficient as normal outlines. But if you go outside of that, it also has to run through the path, the code path that converts the stroke into outlines. So I'd say the next step, if you're curious enough, is to see if you can get a CPU profile to tell you where those 30% of performance disappears. Sure. And if it's not caused by, you can see that on a top, for example, if you run top while you work, no, that's a lie. So if you run top, you will see everything, also the system, the CPU uses. So if you can't see anything special on the Go profiles, or maybe see much of the performance going into swap buffers or something internally in the system that looks like graphics related, I would say the metal backend may have a good chance of making it faster.
Okay. Yeah, let's have a look. So the egg is basically drawn by starting at a center point, going to the edge, and then using line 2 to just walk all the way around, right? But you're saying that I should probably do that using another functionality?
No, I think you're doing it the right thing. You're describing an outline and then filling it. Isn't that so?
Exactly. Yeah.
Yes. That's as fast as you can get with both renderers. If you have a stroke, which is just if you draw something with a path and wants to have a line that follows that path in some thickness, that's a stroke. And you use the clip dots, I think it's stroke up or something like that, to create not an outline that has to be closed, but just a path, sort of like freehand drawing, but with curves and lines and so on. If you have that stroked, then it goes through the slower code path.
Okay, very good. Yeah, no, happy to test the new backend, of course. Yeah. I'll do that and run the analytics again and share them. It'll be interesting.
Yeah, for sure. And if you can collect a CPU profile on your Mac and send it to me, I could help decode some of that. If we can find that 20%, whatever the hot path is doing, that's so expensive.
Yeah. So I think I have them in the repo, actually. If not, I'll just make sure to include them. It's part of the discussion there, so it's absolutely relevant.
I knew that, actually. Sorry, I forgot that you had put them in there.
Okay. Very good. I think that's it.
Any other questions or comments for John? Okay, well, I'm going to stop the recording now. Thanks everybody for coming out.